By now, we have already established an efficient way of finding zeros of polynomial functions. We've been paying attention to the structure of polynomial functions, and we have noticed a few interesting relationships between the features of the equation and its graph. Among other things, we noticed that the degree of the polynomial function is the same as the number of zeros. We also found out that the number of positive zeros is the same as the number of times the terms of the polynomial are changing in sign. Also, all the polynomial functions we dealt with previously, we noticed that the zeros are rational numbers, meaning they can all be made to look like fractions. Are there any more that we can discover about polynomial functions? Let's find out. So let us find the zeros of these polynomial functions. So we need to find the possible rational zeros. So what are the potential rational zeros? We find that out by finding the factors of the constant term, which is 6. And 6 is right here, over the factors of 1, the leading coefficient, which is right here. So we know that the potential rational zeros are positive, negative 1, 2, 3, and 6. I wanted to pause this video so that you can find the zeros of y. And when you're done, resume the video so you can see the rest of it. Okay, so you probably found out that the zeros are negative 1 and negative 2. And then if you plug in any of the other zeros, they don't work anymore. We notice that we have here 2 negative zeros. We know that we are looking for 4 zeros because the degree is 4. And we know that we're going to look for 1 positive 0 because this is positive, positive, and the negative, the sign changes there. No sign change, no sign change. So there's 1 sign change. Therefore, there should be 1 positive 0. We already have 2 negatives, so we're looking for 1 more negative and then 1 positive 0. And we can't find them in our list. So how do we find them? Notice that here we have 0, negative 3, negative 1, and 1. We know that these are coefficients of a factor of y. Now, how does this factor look like? Well, this is the 0, so we'll say it's equal to 0. This is the constant term, negative 3. This is the x variable, so negative 1x. And the last one is 1x squared. So again, here's the coefficient, 1, negative 1, and then the negative 3. Notice that we have quadratic equation here. And we know in first semester how to find the zeros of a quadratic function. We know that we can use either completing the square or quadratic formula. So now let's use the quadratic formula to find the zeros of x squared minus x minus 3. So I want you to pause this video again and try to find the values for x using quadratic formula, and then resume to continue. Okay, so here's the quadratic formula, and let's plug in the values for a, b, and c. This is your a, this is the b, and this is c. So we plug them in here. So b is negative 1, B again, so negative 1, 1 for A, and negative 3 for C, and 1 here. Therefore, x is equal to positive 1 plus or minus square root of 1 plus 12 all over 2. Therefore, we get x equals 1 plus or minus square root of 13 over 2. So we know here that we have two values for x, and they are x equals 1 plus square root of 13 over 2, and the other one is 1 minus square root of 13 over 2. So these are the two missing zeros. One of them is positive, this is positive, and this is negative. So let's find out what is the value of each of these. I'm going to click here. And we have here the values of 1 plus square root of 13 over 2. It's about 2.3. And 1 minus square root of 13 over 2 is negative 1.3. So let's put it here. This is about 2.3. And this is about negative 1.3. So now let's see if we got this right. The zeros are, let me just list the zeros here, negative 1, negative 2, 2.3, and negative 1.3. So let's just check. Did we find 4 zeros? Yes, we did. Did we find one positive zero because there's one sign change? Yes, we did. And we found 3 negative zeros. So now let's check if the graph will verify these zeros. So I have here the equation. All we need to do is take a look at the graph. Okay, so here's the graph, but we don't see the axis. So let's put the axis back. Here's the axis. Now we can't see the zeros. So let me do this. Here are the zeros. So there's negative 2 and there's 1. Now notice that there's another one here. That's the negative 1.3. And the other one is right here, 2.3. So we found all the zeros. However, 2 of them belong to our list of zeros, and the other 2 are not in that list. Now, because they are not rational numbers, because they have square roots, we call them radicals. So these 2 zeros, let me clear this. These 2 zeros are radical zeros. These are radical numbers because they have square roots. There you go. So now we discover that not all zeros of polynomial functions are rationals. It is possible for the zeros to also be irrational. Another name for radical numbers are irrational numbers. So the number of zeros are either rationals or irrationals. There you go.